I'm sure you've heard the news about the latest advancements in aviation technology. Every day, we see headlines about faster, more efficient, and more powerful aircraft taking to the skies. But have you ever stopped to wonder what makes these incredible machines tick? What is it that allows a massive metal bird to soar gracefully through the air, carrying hundreds of passengers across continents and oceans? Jet engines are like the rock stars of the sky. They are the heart and soul of modern aviation, providing the power needed to lift these giant machines off the ground and keep them cruising at high altitudes. But what exactly goes on inside these powerful engines? How do they generate the immense thrust required to propel an aircraft forward at such high speeds? But how do they actually work? Let's break it down. To understand the inner workings of a jet engine, we need to take a closer look at its various components and how they interact with each other. It's a fascinating process that combines principles of physics, engineering, and chemistry to create a marvel of modern technology. Imagine a giant vacuum cleaner mixed with a hairdryer, but way cooler. This analogy might sound a bit simplistic, but it helps to visualize the basic concept. A jet engine essentially sucks in air, compresses it, mixes it with fuel, and then ignites the mixture to produce a powerful stream of hot gases. These gases are expelled out the back of the engine, generating thrust that propels the aircraft forward. Air gets sucked in at the front, compressed by a series of spinning blades, then mixed with fuel. The process begins with the air intake, where large volumes of air are drawn into the engine. This air is then funneled through a series of rotating blades known as compressors, which increase the pressure of the air. The compressed air is then mixed with fuel in the combustion chamber. Boom! It's ignited, creating super hot gases that shoot out the back. When the fuel-air mixture is ignited, it creates a high-temperature, high-pressure stream of gases. This combustion process is incredibly powerful, generating a tremendous amount of energy. The hot gases expand rapidly and are forced out of the back of the engine at high speed. This thrust propels the jet forward. The force of the expelled gases creates an equal and opposite reaction, pushing the aircraft forward. This is the basic principle of jet propulsion, and it's what allows jets to achieve such high speeds and altitudes. Think of it like blowing up a balloon and letting it go. When you release the balloon, the air rushing out of the opening propels the balloon in the opposite direction. This is a simple demonstration of the same principle that powers jet engines. The air rushing out pushes the balloon in the opposite direction. In the case of a jet engine, the expelled gases push the aircraft forward, allowing it to overcome the forces of gravity and drag. That's Newton's third law in action. For every action, there's an equal and opposite reaction. This fundamental principle of physics is at the heart of jet propulsion. By understanding and harnessing this law, engineers have been able to design engines that can propel aircraft at incredible speeds and altitudes. In simpler terms, jets are flying on controlled explosions. Each ignition of the fuel-air mixture is a controlled explosion that generates the thrust needed to keep the aircraft in the air. These explosions happen continuously and in rapid succession, providing a steady stream of power. Thanks to the genius of engineers, these controlled explosions are efficient and reliable, keeping us cruising comfortably above the clouds. Modern jet engines are marvels of engineering designed to operate safely and efficiently under a wide range of conditions. They are built to withstand extreme temperatures and pressures, and they are meticulously maintained to ensure their reliability. So next time you're flying, remember it's a blend of science and a little bit of magic that's getting you from point A to point B. Safe travels. The next time you find yourself gazing out the window of an airplane, marveling at the view from 30,000 feet, take a moment to appreciate the incredible technology that makes it all possible. From the engineers who design and build these engines to the pilots who skillfully operate them, it's a team effort that ensures your journey is safe, efficient, and comfortable. Safe travels and enjoy the magic of flight.